Hello, Vaibhav sir.
Yeah.
So can we start, sir?
Yes.
Fine. Good morning, everyone. A warm welcome to all. It's a wonderful day, and I feel privileged to extend my warm welcome to all the students, my dear colleagues, the guest for the day, Dr. P.N. Sudama. Myself, Professor Navya, Assistant Professor, Department of Electronics and Communication, Dayanand Sagar University, School of Engineering. Welcoming everyone to the guest lecture on recent trends in wireless and mobile communication. Dayanand Sagar University, the Center of Excellence in Education, Research, Training and Innovation, gives an opportunity and encourages the students to value the education and helps to develop their skills. So here we are, standing very strongly as Dayanand Sagar University School of Engineering. I welcome Dr. P.N. Sudha, Professor and Head of the Department, Electronics and Communication from KS Institute of Technology, Bangalore. Welcome, ma'am.
Thank you, ma'am. Thank you, Navya.
Thank you, ma'am, for accepting our invitation and giving your valuable time for us. I also welcome our beloved Dean, Dr. A. Srinivasan, sir, and respected Chairman, Dr. Vaibhav A. Mishram, sir. Welcome, sir.
Good morning, madam. Thank you, ma'am.
Thanks for inviting me, sir.
Good morning, Harshita, ma'am. Good morning, Sudha, ma'am.
Thank you, sir. Good morning.
I would also welcome the coordinator, Professor Divya Shri, who was very supportive in making this session very successful. A warm welcome to my dear students. So welcome all. So I request respected Chairman, sir, to speak few words.
Thank you, Navya, madam. I welcome Dr. Sudha, ma'am, for taking her time out for the lecture on wireless communication. My dear student, it is a very important topic on which our Dr. Sudha, madam, I know her personally also. She will be speaking on. My dear student, most of the time we think that wireless means something without a wire. But my dear student, it is not like that. Wireless, it is only from your mobile to the tower, it is wireless. From your mobile to the tower, it is wireless. Otherwise, it is completely wired. It is completely wired. You might have heard about the optical cable laying down. Nowadays, optical cables are laid down. You might have heard about the optical cables that are under the sea, connecting from one part of the world continent to the other part of the continent. So, madam will be telling us about how the wireless technology had been evolved and where the 5G in the 5G where we are going, in which direction we are going. So, with her rich experience, she will be telling about the wireless technology and where it is going on and how it has started. My dear student, please make the best use of it and try to ask questions. Madam is madam is having a rich experience into this wireless technologies and all this thing. Please try to clarify your doubts and please try to ask whatever the questions that you have in the back of your mind. Okay, so don't carry forward this question. Madam is quite experienced one, so please ask the question. I on this note, I request I hand it over to Navya madam. Navya madam, please.
Thank you, sir. Thank you, sir. So students, it will be a very interesting session today. So please take a book and pen, get ready for the important sessions now. So now I request Professor Divya Shri to introduce our guest speaker to the gathering. Over to you, Divya ma'am.
Thank you, Navya, ma'am. A very good morning to all of you. It's my pleasure to introduce Dr. P.N. Sudha, ma'am, to the gathering. Dr. P.N. Sudha is Professor and Head in the Department of Electronics and Communication Engineering Department at KS Institute of Technology, Bangalore. She obtained her engineering degree from Gulbarga University, Masters from BVB College of Engineering, Hubli, and PhD from JNTUA. She is working at KSIT since 2002 and has got 21 years of teaching experience. Along with teaching, she guides UG and PG students on research projects. One research scholar is awarded PhD under VTU, and 5 research scholars are pursuing their PhD under her guidance. Her research interests include wireless communication and underwater communication. She has published 24 research papers in national conference and international conferences, 32 papers in international journals, 2 book chapters, and filed 1 patent. She is the reviewer and on editorial board of some of the reputed journals. She received President Award and was awarded as Outstanding Women in Engineering by Venus International Foundation, Chennai. Her administrative experience includes head of the department from October 2010 to till date. She is officiating as WIE Chair IEEE and as President IIC Cell at KSIT. She is an IEEE Access Reviewer, life member of ISTE, and Fellow of Institution of Engineers. With this brief introduction, I request Sudha ma'am to take over the session.
Thank you, madam, for the wonderful introduction.
Thank you. Ma'am, you can take over the session now.
Please enable me to share the screen now.
Okay. 2 minutes.
Yeah, hello, Akash. Akash. But this is the same topic on which you are doing the present project also. That is what my concern is.
Sir, that
Imtiaz sir, Muhammad Imtiaz sir. Sir, am I audible? Hello? Sir, Imtiaz sir? Ma'am, just try now, ma'am. Sudha ma'am.
Yeah. Done.
Yeah. Is it able to share now?
Yeah.
Yes, ma'am. Okay.
I think you are able to see.
Yes, ma'am. Yes, ma'am.
Yeah. Very good morning to all of you. First and foremost, I would like to thank management, principal of Dayanand Sagar University for this opportunity. I like to extend my heartfelt thanks to conveners of this program, Dr. A. Srinivasan sir and Dr. Vaibhav sir. Thank you, sir, for inviting me. And I would like to thank my student and professor, Ms. Navya and Divyashri madam for inviting me to take up this session on recent trends in wireless and mobile communication. Thank you, ma'am.
Thank you, ma'am.
Yeah, now I would like to start with my session with a quote. Technology can become the wings that will allow educational world to fly further and faster, even before if we allow it. Recent trends in wireless communication, wireless and mobile communication. That will be the topic for today's session. Yeah. Today's quote, home is where heart is. But today, phone is where heart is. After this lockdown, all of us know that all of us are addicted to our mobile phones. And we think that without mobile phone, we never exist. So with this quote, I want to start with my session. Cellular structure in mobile communication. Before we enter into the mobile communication in general, and in particular, the trends or variations in mobile communication or evolution in mobile communication, just let us look in what exactly is the cellular structure in mobile communication. Remember, the overall area is basically divided into small structures, and each structure is known as a cell. So this is a structure what we are able to see. And at the center of the structure, default, we will be having an antenna if it is center excited. If it is edge excited, the antenna will be placed on the edges of the cell. This antenna, we call it as a base station antenna. And all the mobile users in turn will be communicating with this base station antenna by using wireless mode. From base station antenna towards the other setup, everything is wired communication. As Vaibhav sir told, initially it is only wireless between the mobile unit as well as the base station unit, but all the other things are wired communication. So this is nothing but a small cellular structure, which in turn will be controlled by a single base station antenna, which is exactly placed at the center. And this structure, we call it as a cell. Here, the overall area, when we look from the top end, will appear in this manner. The overall area will be divided into smaller structures, which are hexagonal in shape. And each hexagonal shape, we call it as a cell. Why exactly they have gone for the cellular structure is because the allocated spectrum in case of wireless communication is very much limited. And as the number of mobile users are increasing, to accommodate all the extra number of users, they have divided the overall area into smaller structures and each structure has been given its own base station antenna. And here we can see that this we call it as a cluster. Cluster is a group of cells which are using different set of frequencies. Here we can see that we have A and cell A in one cluster and cell A in the other cluster, indicating that these two cells will be using the same frequency, and this procedure is known as frequency reuse concept. That is, reusing the same allocated frequency again and again so that we can accommodate maximum number of users. This was basically done only to accommodate maximum number of users. And this particular thing we call it as a cluster. And before we enter in deep into the communication concepts, our mobile communication concept, two important things that need to be looked in is uplink as well as downlink. In case of uplink, default, it is nothing but whenever the mobile user wants to establish the link between the base station. That is, whenever mobile user has got some request that has to be transferred to the base station, that request in turn will be transmitted by using uplink. So uplink is nothing but the channel that is designed from the mobile unit towards the base station. And downlink is nothing but a channel that is basically created from the base station towards your mobile unit. That is, whenever base station has got some information, some instruction that should be forwarded to the mobile unit, that in turn will be done by using downlink concept. So this is nothing but the handoff technology. We know that one important concept of mobile communication is nothing but the mobility. That is, mobiles basically support mobility from one place to the other place. So whenever a person is moving from one place to the other place, for example, from cell A to cell B, the control signals from cell A to B must be handed over to cell B. This process of handing over the signal from base station A to base station B, we call it as handoff technology. In case of GSM, we call it as handoff. In CDMA technology, the same procedure is known as handover technology. So handoff is nothing but a process of transferring the mobile user from one cell structure to the other cell. That is, the control signals will be transferred from one cell to the other cell. That is a basic concept of this handoff technology. And in case of handoff technologies, there are two important types of handoff technology. One is the soft handoff technology. The other one is hard handoff technology. Basically, in the first generation mobile, it was hard handoff technology that was used because technology was not well versed with the concept. Now, everywhere we go for this soft handoff technology. First, let us look in what exactly is this soft handoff technology. In case of soft handoff technology, it is simply known as make before break. That is, if a person is moving from cell 1 to cell 2, and if the person is standing on the edge of the cell or on the threshold of the cell, automatically this person will be able to link up with the second base station. So when a person is standing exactly at the center, for a small instant of time, he will be having the connectivity from the base station 1 as well as base station 2. So for a small instant of time, this particular mobile user will be connected to either of the base stations, both the base stations. So such a procedure is known as soft handoff technology. The advantage of soft handoff technology is never ever person will experience any call drop here. But the disadvantage in this complete methodology is here the spectrum used will be more. That is, I'll be using both the channels from base station 1 as well as base station 2. So there will be a small amount of wastage of bandwidth, but there is no call drop technology in case of soft handoff. In case of hard handoff, it is break before make. That is, if a person stands on the edge of the cell, automatically the connectivity from the first base station will be totally removed or it will be cut down. Then only you will be able to establish the connectivity with respect to second base station. So for a small instant of time, the mobile user who is standing on the threshold of the cell will not be getting connectivity from either of the base station. So there are chances of call drop when a person is standing exactly on the edge of the cell in case of hard handoff technology. That is one of the important drawback of this hard handoff technology. So here, this is the thing here. When a person comes on the edge of the cell, until that he will be connected to base station 1. Once he enters into this threshold region, he will be losing the connectivity both from base station 1 as well as base station 2. Again, once he enters into the second base station, automatically he gets the connectivity. So here there are chances of call drop. That is the basic disadvantage of hard handoff technology. Because of this concept, nowhere nowadays they are going for this hard handoff. Basically, they prefer to go for soft handoff so that there is a call continuity from one base station to the other base station. Now we will be looking into evolution of mobile. What exactly is a mobile? How exactly the mobile communication has evolved? That is what we will be learning in this. First generation mobile basically started in 1980s, and second generation mobile came into existence in 1990. Third generation mobile basically was picturized in 2000, fourth generation in 2010, and fifth generation is now 2020. So now we'll be learning what exactly is the evolution of these mobiles, what exactly is the technology variation that has happened from first generation to fifth generation. Introduction to first generation. This network was basically designed with only voice call capabilities. The first generation mobile was basically designed only to satisfy and transmit voice communication. That was a basic concept that was used in first generation system. And this used analog technology for communication. That is analog communication technology. It was a basic technology that was used in first generation. And 1G mobile phones generally had poor battery life, and the maximum speed of 1G was 2.4 kilobits per second. The speed of the data was very less, and the complete communication was designed only for the analog mode of communication. And this had low frequency bandwidth and was using FDMA technology. So FDMA technology was basic technology that was used in order to allocate the channel to each and every user in first generation. And this system consumed a lot of energy because it was not a properly designed system first generation. And here we had a center long antenna installed exactly at the center, and that antenna was kept to monitor maximum users time. So because of that single antenna installation, the energy consumed was very huge in the first generation system. And this system do not support handoff from one network to the other network. This was a major problem there. If a person moves from one network to the other network, handoff was not initiated there because in first generation, there were no standards. Each and every system was using its own frequency range, its own frequency spectrum. So if I buy a mobile from the first generation from vendor A, the frequency used by vendor A was totally different compared to vendor B. So if I want to go or move from vendor A network to vendor B network, compatibility of frequency was not there. Because of that, handoff was not at all supported in the first generation system. That was one of the major drawback of first generation system. And AMPS for the first generation mobile system. This is mobile initiated phone system, was the first mobile phone that was designed in the first generation system. And this was a basic cellular structure that was there in the first generation system. In first generation system, number of mobile users were very less and number of cells were also very less. So each cell had its own base station antenna, and this base station antenna was directly monitored by mobile telephone switching system, or simply it is known as mobile switching center. This mobile switching center basically was monitoring this base station. Remember, wireless connectivity was established only between the mobile unit and the base station. But from the base station towards the mobile switching center, everything was cabled up. Here, either they used optical fiber communication or it can be microwave communication to establish the link between the base station unit as well as the mobile switching center. From mobile switching center, in turn, it was connected to PSTN network. This PSTN network is basically a landline network. For example, if any mobile user wanted to make a call, first his call will be transferred to base station. That is, request will be forwarded to base station by using uplink. From there, the request in turn will be forwarded to mobile switching center. This mobile switching center in turn will look into database. This home location register is nothing but the database that in turn will be maintaining the details of the user, what exactly are the billing details, and what exactly is the amount left out there with respect to call. So all these details will be monitored by the home location register. And VLR is nothing but visitor location register. For example, if a person moves from one area to the other area, then automatically that location details will be updated in case of visitor location register. These were the only two registers that were there with respect to mobile switching center. And these registers were basically used only to maintain the database. So as and when a call request comes from the mobile user, that call request in turn will be forwarded to mobile switching center. Mobile switching center first will look in what type of number it is transmitted. whether it is a landline number or a mobile number. If it is a mobile number, automatically connectivity will be established here itself. Else, the call will be forwarded to the public switching telephone network, which basically considers the landline communication. So landline communications will be initiated with the help of this PSTN network. This was the basic design that was used in first generation system. And this is nothing but frequency allocation in first generation system. In first generation system, the overall spectrum was divided into smaller channels, and each channel was totally allocated for a user. So one complete user was getting this complete channel. We can see that by using FDMA technology, if I have got 100 channels, for a particular instant of time, we can satisfy only 100 different users. That was one of the important things that was done. So this was the basic concept that was done in case of first generation system. And now let us look in what exactly is the drawback of this first generation system. The important drawback of this first generation system was it had poor sound quality. The quality of the signal was not good because they were using analog communication. And in case of analog communication, we cannot use any filters to remove the noise. That was one of the important drawback of first generation system. And limited coverage. Limited coverage because the cell structure was designed only to accommodate limited number of users. So automatically the antenna was designed only for the limited number of users. So here it was limited coverage. And if a person moves from one cell to the other cell, automatically handoff procedure was very complicated in case of first generation system. And here full analog mode of communication, because the complete system was designed for analog communication. So automatically the spectrum efficiency was not completely utilized in first generation system. And it has low capacity because the spectrum allocated for wireless communication is very much limited. So number of users that could be accommodated for a particular time interval is very much limited. That was one of the major drawback of this first generation system. And 1G system was incompatible with one another as they were designed to operate at different frequency range. As I told, n different vendors, they had n different frequencies. Because of that, the user from one system or one network was not compatible to move into the second network because of variation in the frequency. And roaming was not at all supported between the operators. So there was no roaming because of the incompatibility with respect to frequency variation. And security system was very weak here because analog communication system was the basic concept there. And using analog communication system, no encryption algorithms were designed there. And handoff was initiated by MSC. As number of mobile users were very limited, so number of base stations were very limited. So complete procedure was monitored by a single head, and that head was nothing but MSC, that is Mobile Switching Center. So complete burden was on this MSC. That was one of the important drawback of this first generation system. Now let us look in what exactly is the second generation system. What are the improvements in the second generation system? In the second generation system, the important features are it started using a digital communication technique. So from analog communication technique, people moved into digital communication technique in the second generation. And data rate was, that is minimal data communication was initiated in the second generation. And data rate up to 64 kilobits per second was supported in the second generation system. Because it was a digital communication, they started using TDMA technology. So TDMA technology in turn helped to support more number of users per channel. In case of first generation system, one complete channel was allocated only to a single user. Whereas in case of second generation system, the same channel was allocated among 8 different users by using TDMA technology. Now we can think that if I have 10 channels, using 10 channels in first generation, we were able to satisfy only 10 users. Whereas in the second generation system, because of this TDMA technology, we were able to satisfy 80 different users because one channel was allocated among 8 different users. So total number of users that could be accommodated in this case was 80 different users. That was one of the important advantage of second generation system. That is, spectrum efficiency was increased here compared to first generation. Spectrum efficiency is nothing but total number of users I can accommodate within the given spectrum. Because of this TDMA technology, they were able to accommodate more number of users. That was one of the important outcome of the second generation system. In this system, cheaper, smaller, lighter, and sleek phones were designed. Because it was a mobile digital technology, advancement in VLSI came into picture. So automatically they were able to design sleeker and thin mobiles in the second generation compared to first generation system. In this case, roaming was supported. Roaming supported in the second generation because as per the standards, they came up with few standards representing that what exactly should be the frequency range of the spectrum that should be allocated so that all of them should use the same frequency setup. And texting was supported here in the second generation. And GSM was a predominant second generation technology that was occupied at that most part of the world. In second generation also there was an improvisation, and that improvisation they called it as general packet radio service. And this is also known as 2.5G. It is improvisation compared to a GSM technology. And this supported packet switching of data up to 160 kilobits and was introduced in 1995. So the improvisation or movement from second generation to third generation basically happened by using this general packet radio service, which is basically represented as 2.5G. And the next advancement of this GPRS was known as edge technology, which is nothing but enhanced data rate for GSM evolution, also known as 2.5G. And this was using 8 PKS modulation technique and supported data rate up to 800 kilobits per second. And this was introduced in the year 1997. All these systems are nothing but advanced system, and they also supported advanced roaming from one network to the other network. This is a basic architecture of second generation system. Remember, in the first generation system, we had only mobile unit that was directly connected to MSC. Because number of mobile users were less, automatically all these mobile users in turn was monitored by a single head. Now, as the number of users started increasing, there came in between the intermediate setup here. This intermediate setup, they called it as base station system. This base station system main functionality was they were monitoring the functionality of the mobile unit, and they were also taking the minor decision of transferring the handoff procedure from one cell to the other cell without disturbing the MSC. Now MSC in turn was monitoring the base station system. For example, if I take Bangalore and Mysore as two important places, Bangalore will be having its own base station controller, Mysore will be having its own base station controller. So the base station controller of Bangalore as well as Mysore in turn will be monitored by one single head, and that single head we call it as switching system here. So this switching system, master switching system, default will be controlling all this base station controlling unit. In first generation, we had only two registers there, home location register as well as visitor location register. Because number of mobile users were very less, all the database was monitored and maintained in the home location register. But in second generation, number of users started increasing. So only this register was not able to monitor the complete database or maintain the complete database. In order to support the MSC, we got two important register, which is nothing but equipment identification register as well as authentication register. Remember, as and when we buy a SIM and insert the SIM into the mobile, automatically our SIM in turn will be communicating the MSC, the basic equipment identification number of our mobile. That is the number whatever is put up in the mobile, that in turn will be registered in the equipment identification register. So once it is registered, I'll be creating some authentication there. That authentication data in turn will be maintained in the authentication register. Each and every genuine user will be having his own code, and code details will be maintained in the authentication register. So these are the two important registers that came into picture in the second generation, only to increase the security of the user, to increase authentication of the user who are using that particular network. Along with that, we also had this operation and management center. This operation and management center monitored the complete functionality of this wireless network in the second generation. And this is nothing but the TDM. As I told, in second generation spectrum, the spectrum allocation was done by using TDMA technology. That is, each user was allocated, or each channel was allocated 8 different users. That was one of the important advantage of second generation system compared to the first generation. In first generation, one complete channel was allocated to one user, whereas in the second generation, the same channel was allocated among 8 different users by using TDMA technology. Now let us look in what exactly were the advantage of second generation system over that of first generation. This system allows voice signal to be digitized and compressed. That is one of the important advantage. So whenever data is present in the form of digital, we can initiate the data, we can compress the data, encrypt the data, and then transmit the data. That was one of the important advancement of second generation system. Because of that, the frequency spectrum was properly utilized in the second generation system compared to first generation. And in second generation system supported data services for mobile in the form of SMS. So SMS data service was supported in the second generation. It also supported data and voice signals that were digitally encrypted and then securely transferred from source to destination, preventing this eavesdropping. That is, encryption algorithms were designed in the second generation system. And digital signals consumed less battery power here. So mobile sets were more energy efficient than the first generation counterpart. The energy consumption in case of second generation was less compared to first generation because completing is digitized and digitized data was transmitted between the base station as well as the mobile unit. That was one of the important outcomes. Now let us look in what exactly were the drawbacks. The important drawback of the second generation system was it required strong digital signal to help the mobile phones to work. That was the important thing. That is, the connectivity should be properly established so that the mobile signal can be properly transmitted from source to destination. And this system does not support high data rate. As I told, second generation system was basically supporting the transmit of minimal data in the form of SMS. And so that was one of the important drawback of second generation system. And this was unable to handle the complex data. Complex data is when we have pages together, digital data, and has to be transmitted from source to destination. That could not be done in the second generation. That was one of the important drawback of second generation system. And insufficient usage of bandwidth. We know that by using TDMA technology, in a per channel, I can accommodate only 8 different users. So they thought that the number of users, as they started increasing, they were not able to accommodate all these users within that limited spectrum. Because of that, they felt that the bandwidth was not properly utilized. Because of that, they told that it is insufficient usage of bandwidth. Now let us look at what exactly is this third generation system. Hope that all of you brought your mobiles in the third generation. Now we will look in what are the important features of this third generation, how exactly it is better than the second generation, and what exactly are the drawbacks of the third generation. Now, important features of this third generation system is this provides faster communication compared to your first generation as well as second generation. The data communication speed was 144 kilobits per second to 2 megabits per second. That is how the data was transmitted. In second generation, it was just 64 kilobits per second. Now the data communication increased from 144 kilobits to 2 megabits per second. That was the speed of communication here in third generation. And the system was designed to send and receive larger emails. So now third generation system started acting as a basic computers. So they were able to support, transmit as well as receive the larger email. Support internet here. This also supported high speed internet. Because of that, we were able to transmit the data at a faster rate. And the system design was good. That is, good algorithms were designed, encryption algorithms were designed so that we can securely transmit that to destination. 3G network enabled mobile internet. That is how when we started using our network on our mobile. And this used CDMA technology. That was one of the important outcome of this third generation. This CDMA technology basically came into picture only to accommodate those in order to prevent the congestion. CDMA technology allowed several users to share the same band of frequency. In case of TDMA technology, we were able to accommodate only 8 users, whereas in case of CDMA technology, we can accommodate more than 100 users just by changing the PN sequence, pseudo-random sequence. Each user, as and when he comes up with the request, he will be allocated a separate pseudo. Using that sequence, automatically channel will be allocated and he can use that particular channel. Same procedure was used for all the 100 users. That was one of the important outbreak of third generation system, that is CDMA technology, so that they can accommodate more number of users. And this circuit of this generation, third generation system supported both circuit switch network as well as packet switch network. First and second generation were basically designed only for circuit switching network, whereas third generation was supporting both circuit switch network as well as packet switching network. Circuit switching network was basically used for voice communication, whereas packet switching network was used for data communication. And in this system, MIMO, that is multiple input, multiple output, was introduced so that they can accommodate more number of users and so that they can increase the spectrum capacity. And this also supported universal roaming. Universal roaming was supported in the third generation. And this supported multimedia with voice. Initially, we used to get only the photos in the second generation for data, whereas here it started supporting the multimedia along with the voice communication. Now let us look in what exactly is the circuit switching network as well as the packet switching network. In case of circuit switching network, it is like keeping a reservation. If I have a reservation, automatically I have to go and sit only in that particular state. So reserving ourselves or reserving the complete path for transferring the data from source to destination, we call such a type of procedure as circuit switch network. So the line between the transmitter end as well as receiver end was well fixed between them. So whenever I have to transmit the data, I have to use only that particular method. So such a procedure, we call it as circuit switch network. Whereas in case of packet switch network, it is like entering the restaurant without any reservation. When I don't have any reservation, I can sit anywhere in the restaurant. That is a procedure. So by using circuit switch data communication, packet data will be ready and they can be transmitted from anywhere, anytime to the destination. There is no well-established path between the transmitter end as well as receiver. So such a type of communication, we call it as packet switch communication. The advantage of packet switch communication is any number of users can use the resource at any point of time. But the disadvantages, the packets are randomly transmitted from source to destination, and at the destination, they may randomly reach because there is no well-established channel between the transmitter and receiver. Whereas in case of circuit switch, if I'm transmitting packet of data, first packet will reach the destination first, followed by the second packet, because there is a well-established path between the transmitter and receiver. But here, limited number of users can be accommodated by using this circuit switch concept. So both of these techniques were basically used in case of third generation system, whereas in case of first generation, a well-reserved path was established for transmitting the data. And this is the basic third generation 3G network. This 3G network basically consists of three important things. One is nothing but our mobile station, which is nothing but our mobile equipment. Next is random access network, the core network. This core network in turn is connected to the IP network, or it can be circuit switch PSTN network. Remember, core network is basically an extension of the MSC. So in this core network, default, we have two important things. One is nothing but the circuit switch domain as well as packet switch domain. In packet switch domain, we have this SGSN, which is nothing but service GPRS support node. This support node basically transmits packet of data from source to destination. It gives the address data here, it gives the link, it checks out where exactly packet has to be transmitted, and it delivers the packet. And there is no well-established path between the destination as well as the connectivity. Whereas in case of circuit switch communication, all the voice communication was diverted by using the circuit switch domain. And this circuit switch domain in turn was activated by using MSC as well as gateway MSC. This gateway MSC comes into picture whenever I have to make the ISD call. That is, whenever it is an international call, then we will be using this gateway MSC. If it is a national call, it is only MSC that will be considering or that will be monitoring the complete procedure. But if I have to make an international call, then my call request in turn will be forwarded to gateway MSC. Gateway MSC in turn will be finding what exactly is the ISDN number ISDN number we have typed. Depending upon that, it will forward the request to that particular country. So this gateway MSC comes into picture whenever we are making international calls. And this in turn is nothing but the circuit switch network. So this complete thing is voice communications are basically established by using circuit switch communication, and data communication is done by using packet switch domain. So this was a combination in case of third generation system. And here random access network. This random access network basically is nothing but the base station system. This base station system or base station controller basically monitors what exactly should be the antenna size, when exactly signal or the mobile unit must be handed off, what exactly should be the compression rate, and how exactly signal should be transmitted from source to destination. And from the mobile station to the node, everything is wireless communication. From node, everything is wired. So whatever we are seeing in this radio access network, core network, as well as IP network, everything in this case is wired communication. Only the initial part of this communication is wireless communication. So this is nothing but the CDMA technology. We told that spectrum allocation in third generation was basically done by using CDMA technology. The important advantage of CDMA technologies within the allocated channel. In the first generation, it was 1. In the second generation, it was 8 users. Here, they were able to accommodate 100 different users just by changing the pseudo-random sequence. But the important thing is the orthogonality between the first user and the second user need to be maintained so that we minimize the noise. So in case of CDMA technology, one important drawback was as the number of users increased, because all the users are using the same spectrum, just with the variation of pseudo-random sequence. So as the number of users started increasing, the interference level also started increasing. So that was one of the important drawback of this CDMA technology. Now let us look at what exactly is this third generation system. Advantage of third generation system. This third generation system supported universal roaming. So person can roam from one country to the other country. That was basically done in the third generation system. And it gave faster internet access compared to the first and second generation, because here they went for packet switched network. That was one of the add-on things in case of third generation system. Because of that packet switched network, the internet facility or access of internet, speed of the internet was very huge compared to the first and second generation. And this supported high data rate of 384 kilobits while moving and 2 megabits per second while stationary. If a person is moving from one place to the other place, so there should be a handoff from one base station to the other base station. While doing that handoff also, third generation system was able to support the data rate of 384 kilobits per second. If a person is stationary, for example, now I'm sitting and delivering a talk, my mobile is stationary. In that case, it was able to deliver 2 Mbps of data. That was one of the very good outbreak in the third generation system. And it also supported multimedia service on the mobile internet. So it supported both voice communication as well as data communication through mobile internet and enhanced security and performance. The performance level of third generation system was very good compared to the first and second generation. Now let us look in some disadvantage of third generation. There were disadvantages. Here the installation cost was huge, because in the first and second generation system, mobile network was basically designed only for circuit switch connectivity. Now in the third generation, they went for packet switch connectivity. So complete installation of the setup was need to be done there. So high installation cost. Initially, the installation costs were used for the third generation compared to first and second generation. And needs tower placed close to each other to support high density of users. I told that in case of CDMA technology, number of users were drastically increased. But to accommodate all those users, towers must be placed very close to each other. Automatically, the hardware required to install the towers also increased. This in turn gave to the high installation cost. And 3G plan prices are much more higher than 2G. Because in 3G plans, we had an option. If I want to use the mobile data, default, I need to pay extra. If not, if it is only voice communication, it is exactly similar to that of our 2G communication. So initially, the cost of this 3G was huge compared to the 2G mobiles. And power consumption in this case was huge, because applications that were initiated in the third generation were huge compared to the first and second generation. Now, let us look in what exactly is the fourth generation. Now, already we are in the fourth generation. Already people have started moving to fifth generation also, but most of us are still in the fourth generation. Now, let us look in what exactly is this fourth generation. What is the important feature of this fourth generation? And why exactly, or what exactly were the objectives of this fourth generation? The important objective of this fourth generation was spectral efficiency. The efficiency of the spectrally efficient system. It was using 8 bits per second per hertz. The spectral efficiency was very neatly utilized in the fourth generation. And high network capacity. Here, the network capacity was 10 times greater than that of 3G. So they were able to accommodate more users, and data rate was very huge, and speed of communication was very high. So that was one of the important outbreak of this fourth generation system. Nominal data rate at high speed is 100 Mbps at stationary condition and 20 Mbps at 100 miles per hour. That was the speed of data communication. The rate of data communication increased in fourth generation. And in this case, it was smooth handoff procedure across heterogeneous network. What is this heterogeneous network is? Handoff can be made from one network to the other network. That was one of the important outbreak of this fourth generation system. And that was a smooth handoff. Smooth is nothing but soft handoff technology was basically used here. Seamless connectivity and global roaming. Global roaming was one important thing that was also supported in the third generation. Same thing was supported in the fourth generation, but here with multiple networks. At a single point of time, I can get connectivity from a multiple network. That was outbreak in the fourth generation. And high quality of service for the next generation multimedia support. It gave realistic real-time audio, high-speed data, HDTV video content, as well as mobile TV. All these things were highly supported in the fourth generation system and interoperable with the existing standard. Remember, whenever we are designing any communication system, at the back end, I should be compatible with the first generation, second generation, third generation. Same thing was done here. Fourth generation system was not directly installed, but at the back end, it was compatible with the third generation, and improvisation was done on the existing system. So it was interoperable with the existing wireless standards. And all IP system was packet switch. This complete fourth generation system was completely packet switch network. We know that in the first generation, everything was circuit switch. Second generation also was circuit switch. In third generation, there was an interoperability. That is, they were able to operate both the circuit switch data as well as packet switch data. But in fourth generation, everything got converted into packet switch communication. And this is the fourth generation system. Fourth generation was introduced to provide a wide area network for internet access. That was why this fourth generation system came into existence. It provided high bandwidth and broadband. According to the worldwide radio frequency, 4G is a combination of wired and wireless networks in computers. And 4G networks are projected to provide a speed of 100 Mbps while on move and 1 gigabytes per second while on stationary. We can look in that because of packet switch connectivity, we were able to support up to 100 Mbps of data on move and 1 gigabytes of data when in the stationary condition. That was an important breakout of fourth generation system. And this is the basic concept of fourth generation system. A fourth generation provides mobile ultra broadband internet access because whatever bandwidth or spectrum that is available, that will be made available to all the users. And user need to transmit his data in the form of packets. This is how the packet of data are transmitted. A 4G system does not support traditional circuit switch telephone service, but all the internet protocol based communication such as IP telephony. Here protocols were designed basically to support transmission of data from source to destination. And data were transmitted in the form of packets, and these packets can take any path. Only the thing is they should be transferred to the switching node. From switching node, they have to reach the destination, taking any path at the in between. So this is how the data was transmitted from source to destination. The important features of fourth generation system. What are the important concepts or important outcomes of the fourth generation system? It provides an all IP packet switch network for transmission of voice, data, signal, and multimedia. That is, here internet protocols are basically used, and it is a packet type of communication. The protocols that are basically designed for this packet switching network, and these are supports both voice communication, data communication, signal, and multimedia. Whatever data we have, whatever type of data we have, all those type of data can be easily transmitted by using this packet switching network. It aims to provide high quality uninterrupted service to any location at any point. So in case of packet switching network are in fourth generation, the important thing is high quality signals were transmitted uninterrupted from one place to the other place. As laid down in IMTS advanced specification, 4G network have the peak data rate of 100 Mbps on high mobility station and 1 gigabits per second for low mobility. That is like residence. If I'm sitting, I can easily download the data of 1 gigabits per second at a speed of 1 gigabits per second. They provided smooth handoff across heterogeneous network. That was one of the important drawbacks. If a person is moving from one place to the other place, never ever a person gets to know that he has moved from one cell structure to the other cell structure. That was the outcome of this fourth generation system. And what are the different technologies that were used in fourth generation system was OFDM technology. So OFDM technology was the modulation technology that was basically used in fourth generation just to accommodate maximum number of users. And it also had this long-term evolution technology and advanced long-term evolution technology to establish the connection in radio access device. And smart antennas were used. These smart antennas basically supported multiple input as well as multiple output. An IP protocol known as Internet Protocol version 6 was basically used for establish the communication. Voice over protocols were also used here. Ultra wideband frequencies were used, and millimeter wireless communication was basically used. And the quality of service that was given by the fourth generation was really good compared to the third generation as well as first and second generation. It started with the software-defined radios. The software-defined radios were basically used for handoff technology. They were initiating the handoff technology. So this is a basic block diagram of the fourth generation system. You can look in that in fourth generation system, the radio access network is represented as UALD UTMS terrestrial system. This is nothing but the advanced version of this random radio access network. And all the communication that is established here is basically a packet type of communication. And here, the core network, what we represented as simple MSC, is now represented as evolved packet core. Evolved packet core basically supports all this data here. Here we have serving gateway. This gateway, whenever we see the word gateway, it is basically will be used whenever one country data has to be transmitted to the other country. Similarly here, HSS data is nothing but the data that is basically used to check out what exactly is the home subscriber data. In case of second generation, we called it as home location register. Now we are calling it as home subscriber server. Now this server will be maintaining all the database of the user who has brought the SIM from the particular vendor. And the mobility management will be done by using this mobility management entity. So now the burden of this MSC is divided by maintaining different databases here. These databases in turn will be updated as and when a person moves from one place to the other place. For example, if a person moves from Bangalore to Mysore, his location will be directly updated in this mobility management entity. So whenever he gets a call, automatically call will be diverted to MME to look in what exactly is the location of that particular person, and then call will be forwarded to that particular person. So this mobility management entity basically manages what exactly is the present location. So and again, packet data network gateway. This is nothing but the packet gateway. This packet gateway basically transmits the packet of data, whatever we have from source to destination. So this is how the advanced technology that has happened in case of fourth generation system. Now let us compare the third generation with the fourth generation. In case of third generation, we had two important networks. One is nothing but the circuit switch network as well as the packet switch network. Circuit switch network was basically used for voice communication, and this home location register was basically represented the circuit switch network. So whenever it was a voice call, the circuit switch network was activated. That in turn was activating this PSTN. But whenever it was a data communication, that is, if I have to access some data from the internet, automatically my mobile was started with the packet core network. That is, it started transmitting the packet core network, and it started accessing the data from the IP network. Whereas in case of fourth generation, both of these data were merged now. Now we had only one single packet core network. This packet core network in turn was monitoring both the voice communication as well as data communication. From packet core network, it in turn was connected to the PSTN network. This is nothing but the International Mobile Subscriber Identity, and the services, whatever that could be provided, that in turn was maintained in the cloud. So all these complete thing was monitored by a simple core network that is nothing but the packet core. Now, what exactly is the advantage of fourth generation system is the speed of the data was very, very high here, and it has got high capacity. High capacity because it was using CDMA technology. Above it, it also started using OFDM technology. And the cost of this was very low. Supported interactive multimedia voice streaming videos. So we can make a voice calls here. We can interact with the voice calls. Video calls can be done by using this 4G mobile. Provided good quality of service compared to third generation, better spectral efficiency, affordable communication services, and high usability and connectivity anytime and anywhere. That was one of the important outcomes of this fourth generation. Availability of high bandwidth, because they started using CDMA technology, complete spectra was allocated to each and every user. That was one of the important things. Because of that, the bandwidth utility was very high. And good network security. Very good security codes were designed here, algorithms were designed, encryption algorithms were designed, and global mobility. Global mobility was one of the important things. Now, what exactly is the disadvantage of this fourth generation system? The battery usage is more. It depends upon the mobile instrument device what I'm using. Because the number of applications are more what we are using, default the battery usage in case of fourth generation was very huge compared to the previous generation. And implementation was complex. We know that in third generation, it had both circuit switch as well as packet switch. But in fourth generation, complete thing should be converted into packet switch network. So implementation cost was very huge, and also it was complex compared to the previous one. And this is just a comparison between the first generation system, second, third, and fourth generation. We can directly see that the multiple access technique that was used in first generation was FDMA technology, whereas in case of second generation, it was TDMA technology with the partial CDMA technology. This CDMA came up only in case of GPRS technology. And in third generation, it was completely CDMA technology. And fourth also, we are using same CDMA technology. And bandwidth in this case was first generation was using only analog. And in the second generation, we started with 25 megahertz, 25 megahertz, and in fourth generation, it is 100 gigahertz. Because of this wide bandwidth, we are able to upload and download the data at a faster rate compared to the other techniques. Now let us look in what exactly are the important features and introduction to fifth generation system. What is the importance of this fifth generation system? Fifth generation mobile network is a significant evolution of today's fourth generation long-term evolution network. Now, most of us probably might have got this fifth generation mobiles also. Few of the networks are already started with the fifth generation. So what exactly is the important advantage of this fifth generation mobiles? Fifth generation has been designed to meet a very large growth in data and connectivity of today's modern society. The Internet of Things with billions of connected devices and tomorrow's innovation. This fifth generation technology came into existence only to connect the maximum number of devices with minimum latency. And I should be able to upload the download data from all the devices at the same instant of time without latency or without delay. That was the main intention of introducing this fifth generation system. And 5G will initially operate in conjunction with existing 4G. Now also experimental things are happening here. Along with 4G, they are trying to establish this 5G. Before that 5G can take over the 4G. 5G uses radio waves and radio frequencies to transmit and receive the voice and data connection over the communities. Exactly similar to that of here 4G, and from 1G to 4G, the same spectrum frequency will be used by this 5G. Only this thing is the speed of communication will be very huge here, and connectivity will be very huge. And the delay in connection will be very less here in case of fifth generation. Now, important features of 5G are high speed. That is, the device connectivity is very high. It can connect, the mobile phone can connect to more than one device at the same instant of time. That is how the connectivity they wanted here. And high speed. The speed of the connectivity, uploading or downloading data will be very huge. With the blink of the thing, we can download the complete picture, or we can upload the complete picture. That is the speed of the mobile here. And here, high data rate of communication. Data rate is very huge here. Improved coverage area, smart handoff technology, and low latency. Let us look in one at a time. This is the important features of this fifth generation system. Latency, speed, wide range of application, connectivity, more software options, very high capacity, faster response, and connecting to more number of devices. Again, 5G network is basically divided into two important networks. One is nothing but the radio access network, the other one is core network. So all our mobile devices are connected to this radio access network by using the wireless communication. From radio access network to the core network, everything is wired communication here. Either it can be optical fibers. Nowadays, it's optical fiber that is basically used to get the connectivity between the core network as well as the radio access network. This is the basic representation of this radio access network. So radio access network in turn will be connected from the base station towards the central processing unit. The main functionality of this virtual baseband unit pool is it synchronizes the data, it controls the panel, that is control signals will be activated here, it controls the working of the mobile. Transportation is nothing but it monitors what exactly is the mobility rate, and it also looks in what exactly are the channel variations, that is baseband variations. So all these things in turn will be monitored by virtual baseband unit. This complete thing is nothing but the radio access unit. And this is nothing but the core network. As I told, the core network in case of your fifth generation system is advanced version. So here software defined radios comes into picture. Our mobile unit also will be acting as one of the nodal terminal for the core network. It also will be establishing the connectivity between the satellite as well as the your random access network. So this is the overall representation of the fifth generation, wherein mobile unit or mobile equipment in turn will be connected to random access or radio access network. This radio access network basically monitors what exactly should be the rate of data transmission, because here it is wireless communication, whereas after that everything is wired communication. So it is a functionality of the radio access network to monitor, convert the wireless data into wired data, create some sort of compatibility between the protocols, wireless protocols to wired protocols, and then transmit the data to core network. In the core network, we have all these things. Core network basically will be having nano core, which basically will be checking out what exactly is the IP network or protocols it has to use, what exactly is the billing details. It will be maintaining the subscriber details. It also will be maintaining what exactly is the authentication value, coding value, and the compatibility between one network to the other network. And this is the spectrum. In case of first generation system, it was only from around 300 megahertz to 900 megahertz. That was a spectrum. In case of our 5G, we can look in that the spectrum here basically varies. Yeah, the spectrum varies from 900 megahertz to 3 gigahertz. For the wide range of area, you can see that here from 300 gigahertz to 30 gigahertz, it is nothing but the centimeter wave, which is basically used for densely populated cells. And from 300 to 900 gigahertz, it is millimeter wave. This is basically used whenever the cells are placed very close to each other. Now, 1 minute. Yeah, this is nothing but the existing spectrum. So below 1 gigahertz, already we are using this existing frequency. This is basically used for television, Wi-Fi communication from 1 to 6 gigahertz, and from 30 gigahertz to 100 gigahertz, it was basically designed for satellite links. Now we are using all these frequency spectrums in 5G technology. That is one of the important outbreak of the technology. So here, whenever it is a larger cell, we call it as macro cell. Macro cell will be using the frequency range which falls between 300 megahertz to 6 gigahertz. Macro and small cells will be using from 6 to 30 gigahertz. From 30 gigahertz to 100 gigahertz, basically it is 90 gigahertz. We will be going for a smaller cells. So the allocated spectrum for the 5G technology varies from 300 megahertz to 90 gigahertz. Basically, it is represented up to 100 gigahertz. Still, research is going on for this to use this 100 gigahertz frequency range. So this is the basic representation. Whenever the event or whenever we have a larger scale event wherein we have thousands of users, usually we go for smaller frequency range, that is up to 700 megahertz. If it is vehicular communication, default we select a range of from 3 to 8 gigahertz. Similarly, if it is environmental monitoring, then basically it is in the same range. If it is a small residence, then automatically we go for very high frequency, which varies from 30 to 300 gigahertz. sorry, 30 to 100 gigahertz. This is nothing but the antenna system that was basically used both in fourth generation as well as in the fifth generation system. In fourth generation system, they were using sectorial antennas. Now they are going for this massive MIMOs, that is multiple input and multiple output. Many research is happening in this design of this antennas. And MIMO beaming. MIMO beaming is known as smart antenna representation here. Each user will be having its own directivity. The advantage of going for the smart antenna is signal to noise ratio in this case is very less compared to the fourth generation system, or it can be any other lower generation system. Because of the smart antenna, the user will be able to represent his own directivity. So this is nothing but the directivity pattern what the user gets. So signal to noise ratio will be calculated only with respect to this pattern. So noise that is present in the other area will never be considered here whenever we are going with respect to 5G technology. So the important outcomes of this are fifth generation system is massive machine to machine communication. Here it is simply known as Internet of Things. So there is easily we can establish the connectivity between one machine to the other machine. That is one of the important advantage of this fifth generation system. And this involves connecting billions of devices without human intervention at a scale not seen even before. So here we can connect any device to our mobile without the human intervention. That will be done automatically by our mobile. So it is machine to machine communication that will be established here. And ultra reliable low latency communication. When I set up the communication with respect to any device, automatically uploading of the data, communicating with the data will be done with zero latency. That is what is the claim of the fifth generation system. And enhanced mobile broadband. This is providing significantly faster data and greater capacity compared to the previous generations. Low latency. In this case, in case of latency is nothing but time taken for the device to respond. Here, the latency in case of 3G system was milliseconds, whereas in case of 4G system is 30 milliseconds. Whereas in 5G, we call it as 1 millisecond. Usually, we say it as zero latency. As and when I switch on or I want connectivity, automatically system will be established. That is, device will be connected automatically without the human intervention. So this is how the 5G system is designed to establish the connectivity. 5G will enable instantaneous connectivity to billions of devices of Internet of Things and a truly connected world with zero latency. And this is nothing but connected community. So 5G technology can be used everywhere, anywhere, everywhere. So it also helps in establishing the connectivity with respect to the farming. It can be with respect to industry or with respect to any other technology or any other way of life. Here, it can establish inter-vehicular to vehicular communication. It also can establish machine to machine communication, device to device communication. It also can establish two different technologies. That is LTE, long-term evolution techniques, along with Wi-Fi. That is, integration of technologies can also be done by using fifth generation system. Now, let us look at what exactly is a handoff, because we told that we are able to connect to every device at a faster rate, deliver data at a faster rate, move at a faster rate. All these things are okay. But if a person is moving from one place to the other place, the signals must be handed over from one place to the other place. That is, from one base station to the other base station. And this handoff technology, in case of fifth generation, is initialized by using two important techniques, that is centralized method and distributed method. So centralized method, we will look in what exactly is the centralized method. In case of centralized method, we have a base station antenna. This base station antenna in turn will be monitoring the movement of mobile user from one base station to the other base station. This will happen without intervening the base station controller. So in case of third generation, data was initiated to base station controller, whereas here the activity will be initiated by the nodal terminals itself. So they in turn will move the mobile unit from one base station to the other base station. By doing that, the faster way of communication without losing the signal can be established. Such a procedure we call it as centralized. Centralized is nothing but we have a head. Head in turn will be monitoring the movement of the mobile unit from one level to the other level. And in case of distributed system, if I have 100 users, and if the user is moving from one place to the other place, even the traffic pole itself will be acting as one of the nodal terminals. So the signal will be handed out from one equipment to the other equipment or from one device to the other device. If I'm sitting in a classroom, the fan itself will be acting as one of the nodal terminal. And if I'm moving from first bench to the last bench, automatically my signal from the first fan will be handed over to the second fan, from second fan to third fan. That is how the automation will be done. That is the distributed type of handoff that in turn is designed for fifth generation system. And this is the comparison of first generation to fifth generation system. We can see in case of fifth generation system, handoff can be done both horizontally as well as vertically. Handoff is nothing but from the lower level antennas to higher level antennas. For example, if a person is moving from smaller cell, which is nothing but picocell, to macro cell, then automatically handover will be done from lower antenna levels to higher antenna levels. Picocell will be having antenna which is fixed at a lower height compared to the macro cell. So if a person is using vehicle, depending on the speed of the movement, automatically person will be handed over from lower antenna to the higher antenna. So handoff can be done from vertical level to horizontal level or vice versa. That is what is supported in case of fifth generation system. Now, pros and cons. We know that it is common to seek perfection, but it is stupid to believe that you will ever reach it. That is nowhere, none of the person is perfect, and none of the designs what we have designed are perfect. Some are the other ways we have pros and cons there. Now we will be looking in what exactly are pros and cons. Perfection is not a destination, but a journey. Now we will look in what exactly are pros and what exactly are cons of fifth generation system. Fifth generation will support killer speed data. That is, by the blink of an eye, we will be able to upload or download the complete film picture. That is the advantage of this fifth generation system. Lower level of congestion, because here it will happen, it will support both vertical as well as horizontal handoffs, and it also supports distributed type of handoff technology. Distributed is even a single user who is present there will be initiated to transmit the data from one level to the other level. That is one of the important advantage of this 5G technology. And new technology options. Here, in case of fifth generation, we have n different steps, n different technologies by using which we can operate or we can use the support the functionality of the fifth generation system. With increasing network speed, this could open new doors for smart device technology that may not be available. That is, we are talking about AI, artificial intelligence, virtual reality, and much more. We know that all good things come with the cost. Now we're looking what exactly is the cost. Cons. An increased bandwidth means lesser coverage. Remember, whenever we are increasing the bandwidth at 30 gigahertz, the penetration of the signal into the building will be very, very difficult. So increased bandwidth means the coverage or the penetration will be less, the coverage will be less. And radio frequency may become a problem. We know that 5G technology uses radio frequency from 300 megahertz to 90 gigahertz. And all those radio frequencies are already used by some other spectrum. Either it can be radio spectrum or it can be satellite communication. The same spectra is reused here. So there can be some sort of problem while establishing the connection here. That is one of the important drawbacks. And broadcast distance and building penetration. As I told, as the frequency increases, the penetration of the signal into the building will be really difficult. So depending upon the user, depending upon the position of the user, we need to select the frequency allocation for that particular user. And battery drain and heat. Phone is running on 5G will experience a huge battery drainage because many different applications and your mobile is all the time connected to one or the other device. So automatically uploading and downloading of data will be done without our human intervention. So there are chances that there will be huge battery requirement with respect to 5G. Now let us look in what exactly is the research areas that are left out for 5G. Research is to see what everybody else has seen and to think what nobody else has thought. So whenever we want to do some research, we need to think in the other way. So these are the few areas wherein research could be carried out. Massive memory. Now already I told that because of increased number of users, they are going for array type of antennas. The maximum size of the array of antennas that is used as of now is 64 by 64. So there are chances that we can go for designing an antenna system which is more than that 64 by 64 to accommodate more number of users and to reduce the interference with respect to the signal, whatever is transmitted. Centimeter and millimeter wave. upgradation in the design concept to use the unused spectrum. We told that as per the client from the 5G technology, they can use up to 100 gigahertz. But as of now, system is designed only for 60 gigahertz. So there is a spectrum there, left-out spectrum, which could be used by upgrading our knowledge. And multi radio access technology. This is ability to connect different technologies at the same instant of time. Now we know that by using our mobile, present 4G mobile, either I can connect to Wi-Fi technology, either I can connect to Bluetooth, or it can be Wi-Fi. Whereas here, we can connect to both Wi-Fi as well as LTE, depending upon the requirement. I can connect to more than one technology at the same instant of time. That is the research. And battery life. We know that because of many applications running here, battery life will be, huge battery is required here. So 5G system connects to many devices at the same instant of time. So usage of battery in this case is very low. And research into new waveforms or air interface. New air interface techniques must be designed to vary with the type of communication. For example, if I'm going for high frequency communication, I need to go for one type of modulation technique. If I'm going for a lower level of frequency, I need to go for different type. So we need to go do some sort of research here so that we can minimize the battery consumption of energy there and also increase the connectivity. Intelligent data mining on flight. System will be accessing maximum data, so need proper technique for data. One important thing of 5G technologies, it can connect to more than 100 devices at the same instant of time. When it is connected to 100 different devices, it can upload and download the data. So the data, what we are getting is a lump sum data here. So monitoring and maintaining the data is very big thing. And that complete thing will be done by using big data communication. So big data is one important domain, research domain, in order to find out the process of establishing or maintaining the data that is coming from the 5G technology. Yes, that was about the variations from 1G to 5G. If you have any queries, you can shoot out. Any queries from the student side? Yes.
Thank you, Sudhana. Indeed, it was a knowledgeful section. I hope our budding engineers have taken note of it. We have a couple of questions here. Can I read out the questions?
Yeah, please.
So Chaitanya is having one question. Why 5G will require millions of small cells?
Madam, in case of 5G technology, the frequency spectrum varies from 300 megahertz to 60 gigahertz. So when we say 60 gigahertz, that was basically designed for picocell. That is very smaller cell. Even our area itself will be acting as a cell there. So at higher frequency, the area of the cell automatically reduces. Because of that variation in usage of frequency, they have gone for smaller cells, designing of smaller cells, so that they can get better connectivity, better data transfer, and faster data transfer.
One more question, ma'am. In India, we are not getting an actual 4G speed. Then
Yeah.
what is the need of 5G now?
Yeah, in India, still the experimental data setup is done. But in 4G also, you can see once the 4G started, the data rate was less. But nowadays, we are able to get the data rate. And this 5G technology not only concentrates only on the speed, it is how the device can be connected, how automation can be done. That is a basic concept of 5G. So we want to minimize the human intervention and collect the data, maintain the data, serve the data. That is a basic concept here. But still the experimental things are being done in 5G. Only the Reliance people are starting with the 5G there. They are working on the 5G as of now. Yes.
Thank you, ma'am, for enlightening on the recent trends on wireless communication. So now I request Professor Divyashri to give a vote of thanks.
On behalf of School of Engineering, Sagar University, I, Divyashri, take this opportunity to propose vote of thanks. We would place our sincere gratitude to Professor P.N. Sudha ma'am for delivering technical discussion on recent trends in wireless and mobile communication. The talk provided valuable insights into technological advancements from the perspective on academicians and researchers. I would also thank today's event conveners, our beloved Dr. A. Srinivas sir, Dean SOE DSU, and Dr. Vaibhav sir, our beloved Chairman, EC Department, SOE DSU, for their support and continuous encouragement to organize this event. We also thank Mr. Mohammad Imtiaz sir for continuous support in successful conduction in online platform. And special thanks to organizing committee members, Professor Navya R. and faculties of ECE department for their unflinching support and coordination. My heartfelt thanks to students for their active participation, paying attention in listening, and for their learning trend. Thank you all chairmen of different department, faculties of SOE for attending the session. Thank you. Over to Chairman sir. Vaibhav sir, you want to add something to this note?
Sir, Vaibhav sir.
Yes, no, ma'am. I'm here.
So you want to add something to this note?
Yeah.
And last, we got some results for this existing method. So I've designed this method by using MATLAB. So
Something is just, I think the mic.
work
Yes.
which asks the user to enter the message here. So that will be given as an input to the cryptographic algorithm to generate the ciphertext, and that generated ciphertext will be given as an input to the QR code generator to generate.
Okay, I think we are good now. So we have come to an end of our session. I would like to thank everyone who made this session possible. So thank you, Vaibhav sir. Thank you, Dr. A. Srinivasan sir.
The Stego image will
Dean
be
sir.
Hello,
given
madam.
as an input to the
Sir,
signal.
Hello.
hello. Yes, sir. Yes, sir. It's audible, sir.
And it's
Sir,
one.
I think you have to mute that one more presentation which is
Okay.
going.
So from this
It's
decrypted
audible,
message,
sir.
we
One
will
second.
be able to
Yes, sir. Yes, sir. Yes, sir. Now it is fine.
Yeah, fine. It's fine, ma'am.
So please, if you want to share something about this.
Sure,
note-
sure.
Yes, yes.
Good morning, Sudha ma'am. Namaste, ma'am.
Okay, sir. Thanks for the invitation, sir.
Yeah, it was nice, ma'am. Wonderful presentation, and you had shared your experience about the 5G and the wireless communication. I hope it was very much useful for our students, and we will, as a students, our students will make the best use of it. And ma'am, in future, if we need any guidance related to the 5G wireless, I request you to please help our students as well as our staff. With your talk, lot of students have been benefited, student community has been benefited. Also, there were so many staffs who had joined and they were telling it's an excellent lecture we had. We will request you once again, ma'am, sometime if you can give, when you are free, you can visit our place and give one more lecture, interact with the personally, interact with our students and give one more talk, ma'am. It was excellent presentation, ma'am, and it was very thorough, and you had in between inserted the quotes also, which were very well connected with the presentation, and we think that it was I personally think it is very informative, and it was informative for the students. Students are also studying the subject like digital communication. In the next semester, they will be having a subject called wireless communication and all this thing, for which it had created a nice base, ma'am. Now, madam, I am audible, ma'am. Now, madam, I am audible.
Yes, sir. Yes, sir. Yes, sir. You're audible, sir. Yes, sir.
Which had it had created a very excellent base, ma'am. I wholeheartedly thank you, ma'am, once again for sparing your time on Saturday and enlightening our students about the 5G and wireless communication. Thank you so much, ma'am. We will look forward more help from your side, ma'am. Thank you so much. Thank you very much.
Thank you, everyone, sir.
Thank you.
It's my pleasure to share whatever views I have, sir. Thanks a lot.
Thank you, ma'am. Please do visit our campus and try to help us, ma'am, and guide us, ma'am.
Thanks, sir. Thanks for the invitation again.
Thank you, ma'am.
Thank you, Vaibhav, sir. Thank you, sir. Thank you so much, ma'am. As sir told, it was really an informative talk. So we'll be looking forward for your more session, ma'am, even online and as well as the offline, ma'am. So please visit our campus. So I would like to thank everyone who made this session possible. So I especially thank Dr. P.N. Sudha, ma'am. So thank you all once again for attending this session. So that's the end of the session. Thank you so much.
Bye. Take care.
Thank you, ma'am. Thank you. Thank you, students.
Thank you, Mr. Imtiaz sir, and thank you, Imtiaz sir, Navya ma'am, Divya ma'am, and all my dear students for attending the session. Thank you, Imtiaz sir.
Thank you, sir.